Okay, now let's talk about how do exactly, uh, how did we produce electricity? If you look at this video again, say all we need to do is a magnet and force. Okay, um, now this comes to Faraday's law and Lenz's law. Okay, now let me explain what do they Faraday is they both scientists. Okay. Yeah, they name the law using their name, and if you let me show you what I have on my year 12 cheat sheet. Now, they are very important laws. Year 12, yep. Okay. For electronic version, I have this. So let me just go through Faraday's law. What does Faraday's discover is he discovered that the induced EMF, the induced voltage EMF is just understand it as a short for voltage now. Okay. The induced voltage is proportional to the rate of change of magnetic flux. Okay. So that's basically the most important discovery, okay, of mankind, and this discovery leads to industrial revolutions. Okay. Now, what we can say is, okay, the induced EMF, it has this symbol there. It's not a E. Okay. This is the induced EMF is equals to the rate of change of magnetic flux over time. Okay. What this means is, if I have two magnets and I create a magnetic field, and then I lie a wire inside, okay, in them. Okay, imagine this is a top view. I put a wire in them. Now, what I do is, okay, that's step one. All I need to do to create electricity is let me make the magnet disappear. Okay, so yep, if I make a change of the magnetic flux over that wire, there will be current, there will be voltage, there will be induced EMF, okay, induced voltage. So, and we can basically calculate this voltage. Okay. Now, just give me a second. Okay. So, yep. The important part here is, okay, the induced voltage, the induced EMF is basically related to the rate of change of the magnetic field, of the magnetic flux. So the idea is, if you have a magnet, you put a wire inside and leave it like that, nothing would happen. However, if you move the wire out of it, when when there is a change, so the magnetic flux on the wire changed, thus voltage is generated, electricity is generated. Now, yep. Now let's look at Lenz's law. Lenz did some more work on Faraday's law, and he found that the state of induced current, which is will be in the direction. So Lenz's law is dealing with the direction of current, so that it will it will oppose the change made by the change of magnetic field. So, yeah, what I need you to do now is just write down those Faraday's law, and Lenz's law on your cheat sheet. You need them, and yep, and let's basically Lenz's law says um, that the system doesn't like to change. So if the magnetic field changes, so the current tends to move in a way that can produce the missing magnetic field. So yeah, we will do some more work on this, but now let's just go back to the formula. Okay. So what we know is Faraday told me the induced voltage, the generated electricity, is proportional to the rate of change of the magnetic flux over time. Lenz's law told me the direction of current is in the negative direction. So what did Lenz do is he added a minus on that equation. So if you look in your book or in your notes now, we can find the voltage. Let me label all this first. Okay, now let's go to the important equations. Okay. The voltage can be calculated. Okay. The induced EMF is basically minus N. N is the number of coils. So the idea is, we learned that in DC motor. Okay. So N is the number of coils, the number of wires, times the rate of change of magnetic flux over time. Okay, and say now have a look at step 1, step 2. If I want to generate electricity on the wire, okay, if I want the wire has more voltage or current, the easy way I do is, what I can do is, I make the magnets disappear quickly. Yep. If I make the magnet disappear quickly, the rate of change of magnetic flux over time would increase. Thus, the voltage would increase. Okay. So if I make those if I make those magnets disappear slowly, the rate of change of magnetic flux over the time would decrease. Thus, there will be a low voltage. So if we go back to the video, if we go back to the YouTube video, say as this guy turns the as him turns turns the more turns the shaft quickly, the rate of change of magnetic field, magnetic flux over time is increased. Thus, the voltage produced is increased. Thus, the DC motor runs faster. Okay. So as he slows down, the voltage, as he slows down, the change, the rate of change of magnetic flux over time decreases. Thus, the electricity produced decreases. Thus, the motor turns slower. Now have a look. Have a look again. So, yep. Remember this basic equation. Now, have a look at other equation. This equation is about the proportional sign. That's the voltage involves the induced EMF. The current is cannot be calculated. The current can be only calculated with voltage and resistance. But what we can say is we know the direction of the current, and we can say that the current is basically the value of the current is proportional to the rate of change of magnetic flux over time as well. Okay, so this just means when the rate of change of magnetic flux increases, the current will be increased. Okay.